So this is a gas gathering facility is what this is. So all the production that's coming in from the field, it's going to come into this facility. Down on the far end, it first comes into the slug catcher, which is going to take out any of the free water that's traveling with the gas in the pipeline. Then it goes through a series of filtration, and then it comes in. This large line going into the building is the suction header. The suction header, all of these compressors are pulling off of that suction header to compress that gas from a low pressure up to a high pressure. So that pressure can be coming into the facility at 150 PSI, and the compressors are taking that gas and compressing it up to 1400 PSI. Even though we take the amount of gas from the suction header into the compressor building, compress it up, notice how that same amount of gas comes back out in a smaller pipe. Why? Because we just compressed the same amount of molecules into a tighter spot. That's why we call it compression. We compressed it. It's like compressing a file in a computer, right? We took a bunch of stuff, compressed it into a tighter space. Why? So we can transport it. Amazing how it all works together, right? So now we have the discharge header that comes out. And as that discharge header comes out, we go through a vertical coalescing filter right here. Then we go through a horizontal particulate filter that's a filter coalescer also. And then as it comes down, then it goes into this is TPS equipment, goes into our glycol contactor. What happens in the glycol contactor is the gas goes in here at the bottom, travels up through the contactor, comes out the top. Well, these small lines that are silver and insulated have glycol, what we call lean glycol. And we're injecting glycol into the top of the contactor, and it's raining down through the packing, and it's why we call it a contactor or an absorber. What are we doing? We're absorbing the water out of the gas and contacting it with the glycol, because the glycol will strip the water off of the gas molecules. We get that water out, the glycol rains down, ends up in the bottom, comes over to the dump valves and these silver lines and heads back to the regen skids. Why? Now we call it rich glycol. It's rich, it's saturated full of water, okay? It's saturated full of water, we gotta take it over and we gotta steam that water out of that glycol. So we regenerate the glycol to get it back to pure glycol, get rid of the water, and then we pump it back over so it can sit there and do its job again. So it's just a circulatory system. And what happens is the final gas leaves this contactor, what we call dry gas. It's not saturated full of water. And then it goes through filtration, then it goes into the sales meter, and then it goes out to whoever takes it. Now it's headed to cryogenic, to the gas plant, so it can be broken down into its different components. So methane and ethanes and propanes and butanes and everything gets stripped out, cryogenic. And after the cryogenic process, all of those individual pieces go to places that can use them and everything, and then the natural gas, the methane, ends up as a consumer grade natural gas. It goes into households and businesses and everything else. So up on the hill, we have production, came out of the ground. Here on this facility is gas gathering and dehydration and filtration. So we take out the particles, we take out the water, we sell it to midstream pipeline through the sales meter, or maybe the company keeps it, and then they transport it down to the gas plant down in the valleys. You know, different companies have gas plants out here where they take, and now they bring it into a whole refining process. They refine the gas. And after the refining process, then it goes to the consumers.